Hi, pre-calculus students. How you doing? Welcome to sections 5.1 and 5.2. We were going to be together today in class, and that didn't happen. And so I am shooting a video on 5.1 and 5.2, and then you're going to give it your very best shot. And of course, don't worry, when we're together next, we'll talk about the work. This is a section, chapter 5, on trigonometric identities and solving trigonometric equations. It's one of my personal favorites. It's a little different, takes a little getting used to. I come across students who kind of just love this section. And we use trig identities is one of those topics that isn't really useful in the real world, but it is used a ton in higher math. Specifically, we use it a lot in AP Calculus, and that's why it's here. Plus, I like the idea behind trig identities because, again, it really firms up your algebra skills, and it really helps you see the relationship between the different trig functions and just kind of giving you a deeper understanding. Because this video covers two sections, this is going to take a little bit, okay, and involves a few different things I have to pull in. So the first thing we're going to start with is that we are going to look at the chapter 5 memorization worksheet. I don't believe I gave this to you. That was supposed to happen today. And so you'll have to access this on Schoology in materials under chapter 5. There is a pre-calc chapter 5 memorization worksheet. And you can also write it in your notes here in your video notes. So anything you need for sections 5.1 and 5.2, I will have on the board here, okay? So if you are using the chapter 5 memorization worksheet that is on Schoology, you may wanna draw a line, and I'll do that right now. Let's draw that line after number 3. And that just kind of lets you know that for 5.1 and 5.2, those sections, those assignments, you will only be using 1, 2, and 3. There's no need to look at 4, what is that, 4 through 7. Okay, so let me get this on the board though, in case that's helpful to you. So for the chapter 5 memorization, okay, number 1 is reciprocal identities. Which you already know. Now, I hope you don't mind. I get a little tired of writing the word identity, so we will start calling that ID, or ID with a small s. And so these you already know, right? But you are going to find them useful in another way. So cosecant is equal to 1 over sine of x. Okay, you will be using this section 5.1 and 5.2. Secant x is equal to 1 over cosine of x. And cotangent of x is equal to 1 over tangent x. Just want you to know that cosecant 1 over sine of x, secant is 1 over cosine of x. Cotangent is obviously the reciprocal. It's 1 over tangent. You will not use this very often. I'll show you what you will use instead. So very useful here, very useful. I would circle that, very useful. I will not circle cotangent of x being 1 over tangent of x. It is true, not as useful in these sections. Okay, so these you already know. Number 2 on the memorization sheet is your quotient identities, which you know also. Is your quotient identities. There's just 2 of them. Tangent of x equals sine of x over cosine of x. And cotangent of x is equal to cosine of x over sine of x. These are both very useful And again, they're called quotient identities, obviously, because they're quotient. I would circle these. These are very useful. So see here, cotangent being 1 over tangent of x, sometimes used, but it's really more useful in this form that we have here. Okay. Now, I am going to erase and put up C, which is the Pythagorean identities, which number 3, Pythagorean identities. And so be sure you have this down, and I need a little bit more room for number 3. So let's do that next. Okay, number 3, Pythagorean identities. There are 3 of them. The first is kind of what I call the big dog. Like this Pythagorean identity occurs most often. Cosine squared plus sine squared equals 1. Isn't that kind of an amazing thought? First of all, that you know what the cosine wave looks like. You know what the sine wave looks like. You know when you square something, it makes it more parabolic shaped. Isn't that a crazy thought that with these graphs, if you square cosine and you square sine and you add up those 2 graphs, they will flatten out to the y equals 1 line. There's actually good reason for that, okay? I also just want to make the point that these don't have to be x's. Your book uses lots of variables for the angle, such as beta, alpha, phi, mu, theta, x, y. But of course, the identities all still apply. It doesn't matter what they call the angle. So put a big circle on this. This is very, very useful. Here's what I want you to know, though, also, is that this identity can show up in other ways. Notice if I subtract a cosine squared from both sides, then this same identity may appear as this. I would write this. And if you are using the memorization sheet, I would write on the back of it that this identity and this identity are the same because I did legal math. Notice I could go back and actually subtract sine squared from both sides, and then I would have cosine squared equals 1 minus sine squared. So I would take note of these also. A next identity, B, then would be that 1 plus tangent squared x equals secant squared x. Okay, I would put a circle on this. You will be using this a lot. 1 plus tangent squared equals secant squared. How else might this true identity appear? If you subtract a 1 from both sides, notice you would have tangent squared equals secant squared x minus 1. How else might this appear? Notice that if you multiply through by a negative, then negative tangent squared equals 1 minus secant squared x. Are there other ways this could look? Absolutely, right? But it would just be changes from the original. The last one, C, is just the Pythagorean identity you see here, but with cos on the front, meaning 1 plus cotangent squared x equals cosecant squared x. And they would also have the same different formats that you might see here, okay? So when you are using Pythagorean identities to simplify or prove identities, notice what you are looking for. Your pattern is that you see trig functions being squared and you see ones. So when you see that pattern, your first thought is, hey, maybe I can use a Pythagorean identity to simplify my expression or to prove that 2 sides of an equation with trig expressions in it are correct. Now, I just want to show you, how is this true? Cosine squared plus sine squared equals 1. Can we agree? Do I hear you? Agree with me that when you have a right triangle, that the Pythagorean theorem is true, that a squared plus b squared equals c squared. Right, we're going to start with a statement that we believe to be true, and we're going to prove cosine squared plus sine squared equals 1. Okay, Let me go ahead and make a right triangle then. So I have a leg A, B, C, and here's my theta. Okay, let's start with the Pythagorean theorem. And what we're going to do is each step we take is going to be true, and we're going to end up with cosine squared plus sine squared equals 1. Okay, so I need, after the equal sign to the right of the equal sign, I need c squared to be 1. So if I divide it by itself, which means I have to divide everything by c squared to keep that equal, right? Won't I have a 1 here? Now, isn't it true that a squared divided by c squared, I could write as a divided by c with the squared on the outside? And can't I write b squared over c squared is b over c squared? And there's my 1. Now take a look here. A over c. Wouldn't you agree, if you looked at this right triangle, that a over c, that's adjacent over hypotenuse, is cosine of theta? So cosine of theta, you would tell me is a over c. So this a over c is cosine. A over c is cosine. This must be cosine squared. If I asked you what is b over c, you would tell me that that is sine of theta, right? Sine of theta is opposite over hypotenuse. And so b over c is sine squared. There we go. We just proved that it's true. Let's do the same thing for 1 plus tangent squared equals secant squared. So a squared plus b squared equals c squared. Let's take a look. I am going to divide everything by a squared because it's legal. Right? If I can divide everything by a squared. Here I have 1 plus b over a squared equals c over a squared. Let's go back to our triangle. B over a is tangent of theta, right? Tangent of theta is opposite over adjacent. Now c over a, that's hypotenuse over adjacent, right? If it was adjacent over hypotenuse, that would be cosine, but it's the reciprocal of cosine, and so this is secant squared. And it's true. Okay, now we're going to talk about how do we use numbers 1, 2, and 3 on the memorization quiz, reciprocal identities, quotient identities, and Pythagorean identities to work with section 5.1 and then 5.2. Hi, I'm back with section 5.1 hints. So let me first say your 5.1, 5.2 notes I was going to give you today, and we're not together. And so they are on Schoology, both on 5.1 and 5.2. I put them there twice, right? This is what they look like. So what I have on the board is a shortened version of when you look at these notes for 5.1, numbers 1, 2, and 3. So what's written on the board is already here. I just wanted to make sure when we were doing this that we can see it all together, right? And so what I'm going to do with you now is either you can print these notes or you can just write this from the board. On section 3 of the notes, there's A through E, and where they are asking us to simplify these trig expressions. Here are the steps we are going to take. We will only, to simplify trig expressions, we will only be using algebra, such as canceling, distributing, or common denominators, and your trig identities number 1 through 3 on your memorization sheet. That's all you need. That's the tools in your toolbox, okay? What are we gonna do? We're first gonna look for Pythagorean identities, trig functions being squared in ones, 2 trig functions being squared together in the same identity. And if possible, you can't always use a Pythagorean identity. And then we'll see if we can use number 1 and 2 on your memorization sheet, the reciprocal and quotient identities that would turn everything into sine and cosine and obviously simplify our expression, right? So what does simplifying mean? It means that you simplify until you have one term. Every now and then you have two terms and there's no denominators, right? Anytime you write a trig expression in a denominator, you can write it another way in the numerator because of the reciprocal functions, okay? So here's what we're gonna do. There's only three things. Number one, is there algebra I can use? Number two, is there a Pythagorean identity I can use? Number three, can I use reciprocal or quotient? And we just keep running through those three things until we have basically one term, sometimes two, and no denominators. So here we go. 3A. They are asking us to simplify cosine of mu times cosecant of mu. Okay, again, the angle doesn't matter. You can put X's there if you want. Okay, number one, I don't see any algebra I can do. Number two, Pythagorean identity? I don't think so. I don't think I see anything being squared or any ones. So this means quotient and reciprocal. So I'm going to use my quotient reciprocal identities. Cosine, I don't have a reciprocal really or quotient identity for. I'm going to keep it. But cosecant is 1 over sine. There we go. So I'm just going to put cosine of mu over 1 and cosecant I wrote using a reciprocal identity. Now I can use algebra, right? I know how to multiply these two fractions. That would be cosine of mu over sine of mu, right? And now I can use a quotient identity because I know what cosine over sine is. It is cotangent of mu. And I am done. I have one term and no denominators. B. They want us to simplify cosecant squared of theta minus cotangent squared of theta. Number one, algebra. I don't see anything I can do. Here, I can't actually subtract these two terms. They are not alike. Number two, Pythagorean identity. I think so. I have two trig functions being squared, and I have a Pythagorean identity with cosecant squared and cotangent squared in it. I'm going to write it right here. 1 plus cotangent squared theta equals cosecant squared theta. I'm going to use this trig identity. Now there's a couple ways for me to do it, but here's what I think. See right here, cosecant squared is equal to 1 plus cotangent squared. So I am going to put that right here. I'm going to substitute cosecant squared theta here with 1 plus cotangent squared theta. Why am I going to do that? Because it's more simplified, because minus cotangent squared theta. Now I only have one trig function instead of two. I only have one trig function. Take a look here. Now I can do algebra. A positive cotangent squared minus cotangent squared is 1. I am done. I have one term and no denominators. Okay, let's do C. I am going to erase. 3C is it's not harder. It just, you have to be super careful with your algebra, okay? So on C, 1 over 1 plus cosine of x plus 1 over 1 minus cosine of x. Okay, and they want us to simplify this. Okay, notice first, number one, can I do algebra? No, I can't. There's not a common denominator. Number two, Pythagorean identity. I don't think so. I don't see anything being squared. And so no. Number three, reciprocal or quotient? No, right? Because everything, reciprocal and quotient identities turn everything into sine and cosine. I already have cosines. All right, I ran through my three things. What do? I go back to algebra. I am going to get a common denominator, right? If I'm only really allowed one term, I've got two. I need a common denominator. So I am going to multiply the first fraction by 1 minus cosine of x. And the second fraction by 1 plus cosine of x, numerator and denominator to keep them equivalent. They now have equivalent denominators, and that would be 1 plus cosine of x times 1 minus cosine of x. Okay, now let's do the math in the numerator. 1 times 1 minus cosine of x plus 1 times 1 plus cosine of x. There we go. I am still on the algebra portion of my work because I can do some canceling in my numerator. Notice negative cosine, positive cosine cancel, and I have 1 plus 1 is 2. I also feel I'm not allowed a denominator in the end. I really think I need to FOIL this out. And if I FOILed it out, just as you will, I'll get 1 minus cosine squared, right, when I multiply this out. Okay, must not be done yet. I'm not allowed denominators, but wait a minute. So I'm done with my algebra. I've used my reciprocal and my quotient, right? I can't turn anything into sine and cosine. It must be Pythagorean, and it is. I have a 1 and a trig function being squared. If you remember, right, this is the trig expression. We had cosine squared plus sine squared equals 1. And remember that when I subtracted a cosine squared from both sides, my identity, Pythagorean identity, looked like this. So this happens all the time, all the time. You'll have a 1 minus cosine squared, that's sine squared. Or you'll have a 1 minus sine squared, that's cosine squared. Okay, so right here, I'm going to replace 1 minus cosine squared with 2 over sine squared. Now, I'm going to make a quick jump here. I must not be done. I'm not allowed a denominator. I'm going to make a quick jump, and many of you may be okay with it. But just in case you're not, once I make my quick jump, I'm going to back up and show you why it's true. Take a look here. This is the reciprocal of sine. The reciprocal of sine is cosecant. So the reciprocal of sine squared is cosecant squared. So I have 2 cosecant squared of x. Now, is equivalent to this expression. I must be done. I only have 1 term and I have no denominators. But just in case you need it, like, I don't know, Ms. Culver, how you jump from here to here. Let me break it up for you. Here's my 2. Here's 1 over sine times 1 over sine. So take a look. Is my expression here the same as my expression here? Yes, I have a 2 in the numerator and a sine squared in the denominator. This is 2. The reciprocal of sine is cosecant. The reciprocal of sine is cosecant. That is secant squared. So you're welcome to make that jump, or you're welcome to do the steps. Let's look at 3D. On D, they want us to simplify cosecant beta over secant beta. Okay, number 1, algebra. I don't see any algebra I can do here. Just making sure I wrote it right. Number 2, Pythagorean identity. I don't see any trig functions being squared. I think this is reciprocal quotient. Here we go. So cosecant, I'm going to write as 1 over sine of beta. There, big division. Secant, I'm going to write as 1 over cosine of beta. There we go. Use reciprocal identities. Now I'm going to do some algebra, right? I have one fraction divided by another. So I am going to multiply by the reciprocal. There we go. Still algebra to do because I can multiply these fractions. I must not be done because I have a denominator, but that's okay. A quotient identity, I know what cosine over sine is. It's cotangent of beta. Now I'm done. One trig, one expression, and no denominators. Last one for 5.1e. They want us to simplify 1 over tangent squared y plus 1. Okay. Immediately what I see here is Pythagorean identity. I see a trig function being squared in a 1, and I know what tangent squared plus 1 is. It is equal to secant squared. Here we go. I must not be done. I have a denominator. The reciprocal of secant is cosine. So the reciprocal of 1 over secant squared must be cosine squared. And I'm done. I have one term and no denominators. Again, notice this is 1 over secant times 1 over secant. Each of these is cosine. Cosine times cosine is cosine squared. Okay, now we are going to do section 5.2. You don't really need any more tools. We're just using our trig identities in algebra in a different way. Hi, last part, section 5.2. We're going to be verifying trig identities. So nothing new that you didn't learn from 5.1. But the idea is a little different. That you are going to be presented, right? So I'm looking on your notes for 5.1, 5.2 at number 4, right? This is for section 5.2, and there's 3 problems here that we're going to be doing. Notice what we have is really an equation or a trig identity. This left-hand side equals that right-hand side. So what you're going to find is in section 5.2 that these are all true. Every expression that you've been given where a left-hand side equals a right-hand side, a trig equation, they are true. They are true. It is true that cotangent squared over cosecant is equal to 1 minus sine squared over sine. So kind of nice to know these are all true. You just have to almost physically prove it by making the left-hand side equal the right-hand side. Okay, now you cannot cross over the equal sign though. What does this mean? It means that you might be tempted to multiply both sides of this equation by sine or cosecant to get rid of the denominators or to cross multiply. You cannot do that. And here's why. We are trying to prove that this is true. If you multiply both sides by sine, that is a property of equalities of equations that are true that you are using while you are trying to prove it's true. So I cannot multiply both sides by sine, assuming both sides are equal to each other when I'm trying to prove that they are. So what does this mean that I do? This means every single time when I write a trig equation that I'm trying to prove is true is I put a squiggly line down the equal sign, dividing the left-hand side from the right. I am going to work separately with the left-hand side, separately with the right-hand side, just looking over to give myself clues, but without doing any math across the equal sign. I'm treating each side separate. So here we go. First of all, I see a lot of different trig functions going on. I have cotangent, I have cosecant, I have 1 minus sine squared, and I have sine, okay? I think what I would like to do, I don't see any algebra, well, I do see a little bit, I can do here and here. Just so you know, there's a couple ways to go. Could I split the right-hand side up into 1 over sine minus sine squared over sine and reduce? Sure, I could. But then I'd have 2 terms on the right and I only have 1 on the left. So would you be okay? That's what's kind of fun about simplifying in 5.1 and these proving these trig identities in 5.2 is that there's at least 3 different paths you can take on each problem, basically. Okay. Here's what I see though. I do see that 1 minus sine squared over sine, that everything on the right is sine. So I know how to, on the left, turn everything into cosine in sine. So I think that would help me. If I use a reciprocal identity for cotangent, quotient identity for cotangent squared, and a reciprocal one for cosecant, meaning turning everything into sine and cosine on the left, it will look more like the right. So I'm not going to cross over, but I look to get clues. So I'm just going to work on the left right now. Okay, so cotangent squared. I have decided, could I use a Pythagorean identity? Sure, but I need a little bit more. When I see cotangent squared, I'm kind of looking for 1 also, or another trig function being squared to use a Pythagorean identity. Would it work? Yes, it would. You can't go wrong. But my choice of at least 3 different paths is I'm going to turn cotangent squared into cosine squared over sine squared because I need some sines, right? Here we go. Cotangent squared. That would be cosine squared over sine squared. Okay, divided by cosecant, I'm going to write that as 1 over sine. Now, what I tend to do is once I'm on a path, I tend to continue it. I have more work to do on the left because I have algebra, right? Algebra, Pythagorean identity, quotient reciprocal. I'm going to multiply by the reciprocal. I'm going to continue my path. There we go. Notice that 1 sine here cancels 1 sine here. And on the left now, I have cosine squared x over sine of x. Okay, I feel like I've kind of come to an end here on the left. Let me look on the right. Notice that I'm set with the denominator. There we go. The denominators are the same. I just need the numerators to be the same. Is cosine squared equal to 1 minus sine squared? Yes, it is. So what I'm going to do is 1 minus sine squared. My Pythagorean identity says that's cosine squared. Now these are exactly the same and I'm done. Now, could I have said here that cosine squared is equal to 1 minus sine squared and then declared them both equal? Absolutely. Absolutely. Both sides don't need to be simplified like they did in section 5.1. I don't need just one term and no denominators. I just need the left-hand side to physically equal the right-hand side, okay? And again, can be confusing. Good news, at least 3 different paths you can use. Let's try B, 4B. I lost my little paper. Here it is. All right. Here's B. 1, oh, that's not a 1. 1 over tangent alpha. I think it looks like a fishy. I call it, so that's alpha, but I call it fishy because doesn't it look like a little fish? Plus tangent fishy equals secant squared fishy over tangent fishy. There we go. There's my equal sign. I'm going to draw my squiggly line down the equals. I'm not going to cross that. Couple ways to go here. Couple things I see. First of all, there are 2 terms on the left, only 1 on the right. These 2 sides will never be the same unless they have 1 term on each side or 2 terms on each side. Okay. I could turn everything into sine and cosine using reciprocal and quotient. You'd be fine. Here's what I see. I see algebra, okay? Algebra, Pythagorean identity, reciprocal quotient. Why do I see that? Because I do see that on the left and the right, that they both have tangent for a common denominator. I'd like to have that, right? I'm trying to make both sides equal. So here's what I think I need to do. I think I need to make tangent fishy over 1. I think on the left-hand side, I need a common denominator of tangent. because I like it here. I see it right here on the right. I'm going to multiply the top and the bottom of the second fraction by tangent. Now there's a common denominator of tangent. Notice I'm only working on the left-hand side of the equation. And my new numerator is 1 plus tangent squared. Fishy. There we go. Okay, so the denominators are the same. I'm good here, right? I just need 1 plus tangent squared to equal secant squared. I need the numerators to be the same. Is that true? Yes. According to a Pythagorean identity, 1 plus tangent squared is equal to secant squared. They are, I am done. They are now equal to each other. Do I need to simplify both sides? Do I need to get rid of a denominator? No, I don't. They are equal. I am done. If you had turned everything into sine and cosine, your expressions would look different than mine, but they would be true. Last one. For C. Secant, this angle is called phi minus cosine of phi equals sine of phi tangent phi. Draw that wavy line. Can't cross over that. Can I add a cosine to both sides? I cannot. That is a property of equality. When both sides are equal to each other, we are trying to prove that is true. We cannot add a cosine to both sides, anything like that. Okay. Now, can I, number one, do I see algebra? I don't think so. I can't subtract here. There's not like terms, right? I don't see any true multiplication I can do on the right. Number two, Pythagorean. I don't think so. I don't see a 1 or any trig functions being squared. What I do see is reciprocal quotient. I have 4 different trig functions. If I turn everything into sine and cosine using reciprocal and identities, reciprocal and quotient identities, I'll only have 2 trig functions, sine and cosine, and I think that might help me make both sides equal. Let's take a look. Secant is 1 over cosine of phi minus cosine I'm going to keep. I'm going to write that as cosine over 1. Okay. Let's take a look here. Now, again, separately, I'm not doing like crossing over by multiplication, addition, subtraction to both sides. Separately, on the right-hand side, I'm going to write, I'm going to keep my sine, and I'm going to write tangent as sine over cosine. There we go. I don't see anything I can do on the left right now, but I do see on the right that I can do some algebra by multiplying these fractions together. I have sine squared of phi over cosine of phi. I feel like I've come to an end on the right-hand side. I don't see anything I can do. I'm going to look at the left-hand side. What I see on the left-hand side is 2 terms and only 1 term on the right. I think I need 1 term on the left. And plus, notice that the denominator, I have cosine for the denominator, so I think that would help me to keep that denominator cosine. So I need just 1 term on the left. I'm going to multiply the top and the bottom of the second fraction by cosine of phi. Now there is a common denominator, cosine of phi, and my new numerator is 1 minus cosine squared phi. All right, they're not equal yet, but the denominators are. I just need sine squared to equal 1 minus cosine squared, right? Oh, I guess you can't see that green. Let me try again. The denominators are equal. I just need the numerators to be equal, and they are. 1 minus cosine squared is a Pythagorean identity. It is equal to sine squared. And now both sides are equal, and I'm done. I think it's fun. I think it's like cleaning, kind of like it cleans things up and proving things are true. It takes lots of practice. So just kind of enjoy it. I would, you're probably laughing at me. I believe that a good way to handle this section is, hey, if you get through a problem and you're like, oh, I got it, good. If you don't, let it be for a while. It's working in the back of your head. That's called diffuse thinking. Work on something else. Do some other problems. Take the dog for a walk. I can assure you that in the back of your head, it's working that through going, I got stuck there. What can I do? And go back and take a second look at it. Restart it fresh. Look at your chapter 5 memorization and go, is there something here I can use? But more than that, just be kind. Try not to yourself, try not to stress out too much about it. And we'll be together soon to go over it. Give it your very best shot.